How X-ray fluorescence analyze the sample qualitatively and quantitatively. Qualitative simply means which element is present in the sample. For example, whether there is a lead, whether there is a gold, whether there is a silver, whether there is a copper. It only reveals information about the elements, while quantitatively simply means what is the percent of each element exists in the sample, what is the contribution of each element, what is the concentration of each element. For example, what is the contribution of lead? Only 5%. What is the concentration of the gold? This means 40%. So this is the simple XRF graph where on x-axis we have X-ray energy. This is not the incident X-ray. Basically, this is the fluorescence X-ray energy. While on y-axis we have intensity of the X-ray fluorescence. Before discussing this graph into detail, let's briefly describe how XRF works. In XRF, we simply bombard X-ray on the sample, and because of the X-ray energy, the core electron is ejected from the sample. Now there is a probability that this vacancy can be filled by higher energy electrons. So the electron may jump from L shell, from M shell, from N shell. When electron jump from L shell to the K shell, there is emission of photon, and that photon is exactly equal to the X-ray. This is why it is called X-ray fluorescence. Fluorescence simply means emission of photons, and that line is basically represented by K alpha. Here we can see K alpha. Now similarly, when this vacancy is filled by the M shell electron, so and again we have emission of photon, and that photon is represented by K beta. Here we can see. So this K alpha and K beta both we call K lines. K lines. Similarly, there is a probability that this X-ray can cause vacancy in the L shell. Now the M shell electron will fill this vacancy or the N shell. So if the M shell fill, that is called L alpha. If the N shell fill, that is called L beta. And similarly, those L alpha, L beta, we call L lines here. This is how we get X-ray fluorescence. Now let's explain that how this X-ray energy is basically talk about the qualitative analysis. How this X-ray energy on the x-axis reveal that which element is present, whether it is gold, whether it is lead, whether it is copper or something. Yeah, it is clear. Every element produce their own characteristics X-ray. So this simply means that when we get this X-ray here, so this means that this X-ray have one kind of energy. For example, we know that the binding energy of the lead is one type, while the gold is another type. Now, if we take another atom here, so this K alpha line will have different value. So this simply means that this peak belongs to gold. This peaks cannot be belong to copper or zinc, because the binding energy of copper is different than the binding energy of the lead or gold. This is why the x-axis will basically talk about the qualitative analysis. This means which type of element is present. Yeah, this is very clear. This value is very important here, and this value is basically this photon emission value here. While on the y-axis, this is basically talk about the quantitative. What percent of each? This simply means that the copper is more here than the gold. Yeah, the presence of copper is more here because the concentration of copper is more here. If you take the sample in the there is a gold in the sample, and there is a copper, and there are some other traces elements. So this means that in that solution, solid solution, or what you call, the contribution of the copper is more. Why? Because we know from this peak value here, this intensity, because we get more emission here, more photons per this copper is compared to the gold when we bombard X-ray on the sample. This simply means that this peak look like, if you zoom it, if you magnify it, it will look like this. This means that the peak intensity, or the simple intensity, is basically the area under the peak. So let's suppose that all peak have the same shapes. So now any peak have higher intensity, mean the height is more. This means that the intensity will be higher for that. This means that the concentration of that element will be higher in that sample. Very simple. This is how the y-axis basically talk about the quantitative, the percent, while the x-axis basically talk about which element, whether lead is there, whether gold is there, whether copper is there. So this is how we talk about qualitative and quantitative analysis in X-ray fluorescence.